All right, let's talk about normal distributions. So we've got some kind of data set, could be from people, from objects, from animals, all kinds of things in the world. And what we find is many things follow this normal distribution curve. Okay, they're just distributed in a normal way, a normal, predictable way, which allows us to do a lot with that. And we get the curve that looks kind of like this. You can see it here in front of us. If I can get my pen to move here, what's going on? And so right in the middle, this represents the mean, okay, or the average. So I'm just going to put the mean right there. And then we've got one standard deviation to the right, one to the left, two to the right, two to the left, three, three, so on and so forth. And so I want you to look at these numbers. So about 34% is what we find. About 34% of the population, whatever it is, falls within this first standard deviation. Another 34%, notice they match, falls below, just within one standard deviation. So notice we add those up and we get 68% of the population is within this one standard deviation above or below the average. We keep going, okay, we get another 13.5, 13.5. If we add those two up, we would get about 95% of the population within two standard deviations. And then we've got a little bit out here, a little bit out here, and it keeps going. So every standard normal curve, this is key, every standard normal curve has the same percent distribution. When it's normally distributed, about 68% within one, about 95% within two. Then we got a little bit beyond, a little bit beyond. That's the big idea. Let's go look at an example and apply that. So let's talk. So we've got a data set and it involved heights of men in this particular study. The results are normally distributed. Okay, that's key. That tells us that, oh, we can use this curve. The mean is 70, so I'm going to label my curve. So 70 inches right in the middle. The standard deviation is 3. So that means one standard deviation away would be 73, 76, 79. And then we could subtract. We could go the opposite direction. So 67, 64, and 61. Now that doesn't mean you can't have people who are taller or who are shorter. Of course that happens, but they're relatively quite rare. So the vast majority are going to fall within this scale that we see. And when I'm doing some of these on my paper, I don't draw the curve every time. I maybe just draw a line and label it, put my average in the middle, and then 1, -1, standard deviations. Just identify those and write these percents. So just keep this in front of you as you're working some of these problems. So let's look at problem 1. What percent of men are between 67 and 70? Well, let's look. So 67, 70, notice? Oh, 34%. So our curve tells us that. Number 2, what percent are between 73 and 76? We look over here. Oh, 13.5%. No problem. And they could have given us whatever. They gave us ones that were just between. What if they'd said 67 to 76? Then I would have added this up and this up and this up to get the overall percentage. Okay, so they can ask us all kinds of things. Let's look at this last one. Suppose there were 200 men. How many would be between 64 and 70? 64 and 70. Good. So let's look at that. So that's from here to here, right? Well, what percent is that? 34 plus 13.5. 34 plus 13.5. Of course, you plug that in a calculator if we need to, but that is 47.5%. So 47.5% of our population is between those two heights. So if there's 200 men in this particular study, we're just going to multiply 200 times 47.5, which is 0.475, and we're going to get our answer there. Let me just bring up my calculator quick. So 200 times 0.475, again we're finding 47.5% of 200. Hey, we get 95. And so this would be 95 men would be in between those heights. Okay, hope that helps. And again, we can apply this to all kinds of things. The key is the situation is normally distributed. and then these percentages apply, and they're going to be very, very similar problems.